Let's solve this equation for x. In other words, find the value of x. On the left hand side, you can see that there is a multiplication between the same bases, that is -8. So we can apply the product rule which says that write the base and add the powers. By doing so we get -8 whole power x plus 2 plus 5, which equals as it is. Now there is a simple rule that when the bases are equal, powers are also equal. Here the bases are -8. So we can equate the powers. We get x plus 2 plus 5 equals 10. Which means x plus 7 equals 10. In order to isolate the x, let's bring this 7 to that side. If we do that, it becomes -7. We get x equals 10 minus 7. Therefore, x equals 3. Now let's solve this for x. As you can see here, the bases of the numerator and the denominator are same. So we can apply the quotient rule for the exponent, which says that if we bring the denominator to the numerator, then the power of the denominator becomes its opposite sign. Here we have x plus 2. So it becomes minus of x plus 2. And importantly, we should put brackets for x plus 2 after the negative sign, because this negative is for both terms, that is for both x and 2. Now distribute the negative sign into the brackets. So it becomes 2 power minus x minus 2. At this moment, the bases are same, so we can apply the product rule which says that write the base and add the powers. By doing so, we get 2 power 2x minus 1 minus x minus 2, which equals 4. Now, grouping the x terms first, which are 2x and minus x. Then the constant terms that are -1 and -2. So 2x minus x equals x and -1 minus 2 equals -3. Remember that our aim is to find the value of x. For that, here on the left hand side we have to isolate the x, which means we have to get rid of this base 2 and -3. First, let's get rid of the base 2. For that, let's rewrite this right hand side 4 as 2 square. Now like previous problem, since bases are equal, powers are also equal. So we get x minus 3 equals 2. Now if we bring this -3 to that side, it becomes +3, which means x equals 2 plus 3. Therefore, x equals 5. The thing is, whenever we solve an equation or whenever we want to find the value of a variable, isolate the each term to one side of the equation wherever the variable is, and get rid of all the other terms to another side of the equation. Here, in this equation, the variable y is on two sides. I'm gonna go ahead and bring this 3 power y to the left hand side. We get, always you have to write first whatever already on this side, that is 3 power y plus 2. And when I take plus 3 power y to the other side, it crosses the equal sign, it becomes minus 3 power y, which equals 216. So what we have done so far is, we isolated all the y terms on the left hand side of our equation. Here we could undone the product rule of exponent, that is 3 power y plus 2 can be written as 3 power y times 3 square. Now on the left hand side, they have 3 power y in common. So we can factor one of them out. we get 3 power y times 3 square minus 1, which equals 216. Some people might think here this should be 0, but actually it is not, since if we multiply 3 power y by 0, we get 0, not 3 power y. So if we want 3 power y, when we multiply itself by some number, the only number is 1. That's why we call the number 1 as multiplicative identity. So in the bracket, 3 square is 9 and minus 1. We get 3 power y times 8, which equals 216. Now let's hold the 3 power y and bring the multiplication of 8 to the other side. By doing so, we get 3 power y equals 216, and if I take the multiplication of 8 to the other side, it becomes division of 8. If we strike the numerator and the denominator by the common factor 8, we get 27. Our aim is to find the value of y, so we have to get rid of this base 3. For that, I am going to write this right hand side 27 like 3 coming in the base. There is only one possibility here, which is 3 cube. Now since the bases are equal, the powers are also equal. Therefore, y equals 3.